Lesson 2-2, solving one-step equations. Our objective today is to solve equations by using addition, subtraction, multiplication, or division. They're actually equality properties because if you've got an equation, one side equals the other side. If you want to add something to one side, you must also add it to the other. It's called addition property of equality, and the same thing is true for the other three operations. Whatever you do to one side, you must also do to the other side. The standards that we will use today from Algebra 1 would be 2-1, 2-6, 9-1, 9-4, and 9-5. When we're solving one-step equations, we're going to undo one operation. That's why it's called one step. You do basically the opposite of what you see. To take it across the equal sign, you must do the opposite. So we're going to look at 5 examples, and then I've got a couple other things that I do want to mention before we finish off. So let's start with example A. It says h minus 12 equals negative 27. Now, I am going to ask that when you do your homework, you write the equation down and you show your steps right below it. Okay, there's no way around that because eventually the equations are going to get longer and more complicated, and I want you to have the steps down pat as you go. If you do not show the work, you will not get credit for doing the problem. So we need to isolate h and get h alone. So if it says h minus 12, you do the opposite of that, and you would say plus 12 below it there, and plus 12 below the number on the other side. So we are doing the opposite of what we see. We're getting h alone, so you're going to add 12. That causes the minus 12 and plus 12 to cancel, and h would equal, and now we're combining integers. So if you're in the whole 27 and you gain 12, you would be at negative 15. So therefore my answer should include the variable, and it should say h equals negative 15. That's the work that I would want you to show. Example B. C plus 102 equals 36. Again, I want to isolate C and get C alone. Well, a positive 102 is keeping it from being alone. So to make the positive 102 cancel out, I would subtract 102 from each side. That causes the 102s to fall away, and C would equal, well, if I have 36 but I lose 102, I would end up with negative 66. Questions about that? Ben? Okay, example C, negative 6x equals 42. So we need to isolate x by itself, and you have to undo whatever operation is there. So what am I going to do?
You're going to take negative 42 divided by negative 6.
Okay, how about divide both sides by negative 6?
Yeah.
Not just the one side, you got to do both. Okay, so divide both sides by negative 6. Now what?
You put x equals negative 7.
Okay, what am I going to do about the negative 6's though?
You cross out the negative 6.
Yep, cross out the negative 6's, and I write
X equals negative 7.
x equals negative 7. Okay, example D, y over negative 3 equals 12. Ariana, what operation is right here with y and negative 3? Division. So how are we going to undo a division?
Multiply.
And what am I going to multiply by?
Negative 3 on both sides.
Multiply by negative 3 on both sides.
Negative 3 is crossed out.
The negative 3's cancel out.
Y equals negative 36.
Y equals negative 36. Okay, the last problem there, 2/5 R equals 8/15. We need to talk about this one a little bit. It is a fraction times R. How do you undo times, Maitri? You multiply by the reciprocal. It's really times, so you really need to divide. We don't divide fractions, so when there is a fraction with your variable, you multiply by the reciprocal. And what is that reciprocal? 5/2. So both sides you multiply by 5/2. What happens on the left? These cancel out and you're left with R. What happens on the right? Okay, hold on a second. Let me change my color. The 2 becomes a 1 and the 8 becomes a 4. And? Okay, the 5 becomes a 1, the 15 becomes a 3. All right, now what? R equals 4/3, and you definitely may leave it 4/3. We talked about that in algebra. You are more than welcome to leave it. In fact, we would prefer that you left your answer 4/3 instead of changing it. You might want to leave your notes out. I got to show you something very briefly. So R is equal to 4/3. I do want to say one thing about problems that might look like this. Let's say you got the problem x plus -4 equals 10, something like that. We do not do double signs. So you need to rewrite that problem from the beginning. So because these signs are different, we would write x minus 4 equals 10. Okay? We won't go on and finish that one, but I just want you to be aware, if they throw double signs in there, do not deal with double signs. You rewrite the problem from the beginning and then proceed to solve it. Are there any questions?